Hello everyone, we are the Panther Pack and we are part of Dr. Jacobs' Spring 2015 Applied Aerodynamics class. For our project, we chose to design a next-generation military transport aircraft. This is the list of our group members and their main contributions. Ryan Welniak, Propulsion; Cody Kaganen, CAD Models; Austin Walker, Aerodynamics; Jeffrey Gervais, Avionics and Control; and me, Zach Zafar, Structures. Here are the requirements that were set in the RFP for the AIAA military transport design. A range of 6,300 nautical miles with payload of 120,000 pounds, max payload of no less than 300,000 pounds, should not take more than 20 minutes to reach cruising altitude with a load of 205,000 pounds, climb speed should not exceed 250 knots below 10,000 feet, cruise Mach should be no less than 0.6. The aircraft must be able to return to base with half of the total engines inoperable. The cargo volume must be able to accommodate 44 463L master pallets, 41 M104 Wolverine heavy assault bridge. Here is the CONOPS for our aircraft. The mission will consist of loading the payload, climbing to cruise altitude, cruising for an extended period of time, descending to drop the payload, and then returning to base.
We began our design by looking at heavy-lift cargo planes currently on the market and comparing their specifications to our design requirements. We use these planes as benchmarks for our design. The heavy-lift cargo plane family is full of many great planes, but many of them couldn't come close to meeting the requirements put forth for this project by the AIAA. There are 4 major planes that are on the market now that come close to meeting our requirements. Even though these planes didn't meet all of our requirements, each of them gave us valuable information to aid in our design. The AN-225 is the largest cargo plane in the world. It is capable of carrying over 500,000 pounds. Though the plane is outdated at 26 years old, it is still the best aircraft to use for our benchmarking. One of the downsides of the AN-225 is its takeoff distance of 11,482 feet, significantly longer than our required takeoff length of 9,000 feet. Another downside is its range of 4,200 nautical miles, calculated using our range spreadsheet. This is much shorter than the 6,300 nautical mile range that we are required to have. One final problem with the AN-225 is that it can't fit all 44 of the 463L pallets. Though this plane does have its problems, it came closest to meeting our requirements, so we decided to use it as our main benchmark. The next best aircraft was the Airbus A380. This plane is capable of carrying over 300,000 pounds, but its cargo bay posed a lot of issues. The cargo bay is only loaded from the front, meaning that the cargo must be loaded by cranes or elevated loading machines. This would be bad for our military aircraft because in the field, ease of loading is very important. The cargo area is also unable to fit any Abrams tanks or the M104 Wolverine heavy assault bridge.
The third best aircraft that our group compared was the Boeing 747-8F Freight. This aircraft, at only 5 years old, is the newest aircraft that we compared. The max payload of the 747-8F is 295,800 pounds, close to but not quite the required 300,000 pound minimum max required payload that our project is based off of. One problem with the 747 is that, like the A380F, being low configuration aircraft, both have to be tall enough so that the engines aren't dragging on the ground. This means that it is loaded through the tall nose. This loading style means that the cargo must be lifted using a crane or elevated loading system. The 747 also does not meet the takeoff distance requirements. It takes off in a distance of 10,138 feet, over 1,000 feet longer than the design requirement. Because this aircraft is the most modern of the aircraft we compared, we knew that it probably would have the best engines currently on the market. We found the Gen X made by General Electric engines would be the perfect fit for our aircraft, being one of the most efficient in thrust-specific fuel consumption out there on the market today. The final aircraft that we used in benchmarking was the C-5 Galaxy made by Lockheed Martin. This aircraft was important to the benchmarking process because it is the only military aircraft in our top 4. This military background helped us to see the differences between a versatile military transport and a civilian transport aircraft. One of the important features of the C-5 is its high wing configuration, giving it the ability to be loaded from the front or rear, meaning the aircraft is lower to the ground. From this, vehicles can be driven into the plane rather than be loaded by a crane or high-lift device. Another important feature of the C-5 is its short takeoff length of 8,400 feet, which is shorter than the 9,000 feet required for our project. A few of the downsides of the C-5 are the cargo space can't fit everything that we required ours to carry, and its payload of 270,000 pounds is just short of our required 300,000 pound minimum max required payload.
I will be introducing T-13 Titan, which is designed to meet AIAA requirements for a next-generation military transport aircraft. It has a gross takeoff weight of 1,398,000 pounds, an empty weight of 419,000 pounds, and a max fuel weight of 673,000 pounds. It has a max payload of 302,000 pounds and can travel 6,340 nautical miles at an altitude of 35,000 feet. Its cruise speed is Mach 0.84 and max speed is Mach 0.98. The 4 next-gen engines can produce a total of 304,000 pounds of thrust. The total wing area is 9,800 square feet with a wingspan of 280 feet. The aircraft has front and rear gates for loading cargo, along with a traditional tail style. The aircraft was designed to carry a large payload a long distance with minimal loss in energy.
What makes the T-13 Titan the best? First of all, its cruise altitude of 35,000 feet. It has a max speed of Mach 0.9 and a cruising speed of Mach 0.84. This is the fastest of its class for heavy lift transport aircraft, which allows you to get from point A to point B faster and be able to deliver the much needed supplies to where they need to go. The T-13 Titan also has a larger cargo bay volume than any other plane in its class, being 162 feet long, 22 feet wide, and 13.12 feet tall. This allows for the T-13 Titan to carry its required amount of 43 6L master pallets. It also allows it to carry an assortment of military vehicles, including 2 M104 Wolverine assault bridge tanks, 2 M1A Abrams battle tanks, 4 M3 Bradley infantry vehicle tanks, and 2 Apache helicopters. This allows for assortment of cargo capabilities and missions. The T-13 Titan can also travel 6,315 nautical miles with a payload of 120,000 pounds. This beats all other current heavy lift transport aircraft flying today. It also has a max payload of 302,000 pounds. The T-13 Titan also has some of the most fuel-efficient engines by almost 15% out on the market today. This allows for longer hauls and saves on the cost per pound to haul per nautical mile. It also allows for the capability to haul more, as you will not need to carry as much fuel to go the same distance. The T-13 Titan can also take off in less than 9,000 feet, with its maximum payload of 302,000 pounds. This allows for you to get in and out of hostile situations fast. With free and front-end loading, it also gives you the option to do airdrops and bring faster loading and unloading times to the battlefield when on the ground. So overall, the T-13 Titan meets all the requirements set forth in the RFP given for the AIAA Heavy Lift Transport Aircraft Competition. This cannot be said for any other plane on the market today, and is why you should buy the T-13 Titan. It also will be manufactured using the highest grade of materials and technology. This will include a full glass cockpit for easier navigation and flying, most likely using the Esterline 9000 system, as this system allows for monitoring of main aircraft systems, navigation, collision awareness, weather, and landing approach assistance, and a whole lot more capability. which will be helpful when landing and flying in tricky situations. The T-14 Titan will also be controlled by a fly-by-wire system, as this allows for easier control of the aircraft and less strains on the pilot, allowing for a pilot to fly longer and more often. Thank you for watching our presentation of our solution to the AIAA Heavy Lift Military Transport Aircraft. This is Team Panther Pack signing off.